In this video, we are looking at an engineering site inspection of the building at 146 Karangakape Road in Auckland. It was done as part of the Civil 745 course on assessing the seismic performance of existing buildings, and I carried it out on August 12, 2025. The building we are looking at is at 146 Karangakape Road in Auckland. It sits up on a red line, and there aren't any geological hazards nearby. No risk of rock sliders or landfills from neighboring hills. Looking at the ground conditions around the site, there is no exposed rock on the surface, and nothing that suggests any risk of liquefaction or lateral spreading. So, based on the overall type and shape of the building, we will go with a site class C. Alright, so here is what we've got. It's a two-story, stand-alone, unreinforced clay brick masonry building. On both sides, there are already buildings in place. The one on the left looks like it's steel masonry underneath, just had a facelift with some finishing work, and it's a bit shorter than ours. The one on the right is brand new, reinforced concrete construction. So yeah, I don't see any real risk of debris from either neighbor dropping onto our building. Next, let's check the separation gaps between our building and the ones on either side. Starting with the right side. At the first floor level, the gap is roughly 30 to 40 millimeters. You can see bits of debris stuck in there, and as we look further down, the gap actually closes up at ground level. Now on the left side, we can't see the gap because of the facade decoration, but we are assuming it's about the same as on the right. Now look at the non-structural elements up high. We can see the front facade has one triangular gable and two parapets. We don't have a clear view of the parapets on the sides or at the back, so I'm going to assume they are similar to the two at the front. Since I couldn't get up on the roof and couldn't fly a drone of the site, I went onto the Auckland Coder's GeoMaps website to grab a high-resolution view from above. Here, we are looking at the condition of the front gable wall and whether it's actually tied into the roof structure behind it. From this image, we can see the shadow it casts on the roof, which suggests the cable is sticking up and leveling above it. So we will assume this is cantilevered architectural feature. The plan view from the Auckland Coder was pretty useful. It clearly shows that the roofs of the three tenancies share a single ridge line running down the middle. If you look back at the shadow from the front triangular facade, you can see it seems to rise straight up from the roof diaphragm. There is no visible design of any bracing to either the front parapet or the side parapets. And finally, if you look closely at the plan view informed for the sides and the rear of the building, you will notice there are no shadows from the parapets onto the roof. So I'm assuming those parapets are fixed directly into the roof structure. One last thing the plan view shows us is this building doesn't have a chimney. Another thing to note on the front facade, the lintels above the windows are just decorative mortar work, so we are assuming all the windows are actually masonry arches. Looking at the wall morphology, it's clear the walls are clay brick masonry. On the front facade, you can clearly see ventilation gaps, and the same thing shows up on the neighbor's side wall. So, even though the brick work on the front is in Flemish bond, we are still assuming the external walls are cavity walls. Since we couldn't find any more evidence on site to confirm the wall thickness, we will go with the usual assumption that there is a single outer leaf and the total exterior wall thickness is about 270 millimeters with a 50 millimeter cavity in the middle. We couldn't do a full inspection of the interior walls that separate the three tenancies, but looking at the interior walls of other buildings on the same street from the same area, we will assume these two interior walls are double leaf masonry, about 230 millimeters thick overall. Where we can, it's always good to check all the wall surfaces on the building to see if the material properties differ from one side to another. But in this case, I couldn't get a look at any of the exterior walls. So for this assessment, we will check a side wall of the neighboring building instead, and use that to determine the material properties for the whole building. The first thing we will probably notice when looking at the side wall is that the mortar joints are pretty much fulfilled. I don't see any clear signs of repointing on the surface. I even scratched the mortar with my key. It's really hard. So I'm inclined to think this is stone lime mortar. So we will take this mortar as representative of the whole building. I also give one of the bricks a scratch with my dog key. It's really hard. So I'd say, generally speaking, the bricks are strong and good quality. Since I couldn't get a look at the timber floor diaphragm inside our building, I went and found a floor in another building from roughly the same area and took a look at that instead. In this first photo, you can see the joints generally span across the short side of the building, which usually means they are running parallel to the street front. In the video, you can see the floorboards are tightly fitted together with barely any gaps between them. I couldn't spot any signs of water damage or rot, and there's no evidence of insect damage like a boiler, so I'd say the timber in this diaphragm is generally in good shape. The last thing we need to look at is how these flexible timber diaphragms are actually tied into the masonry walls. Now, since we can't see the side walls, there is no way to tell from the outside exactly how the floors connect to the walls. So instead, we will take a cue from the Australian Masonry Structural Guide. If you look at the fig 7.1 over on the left, you will see the recommended detailing for multi-story masonry buildings. In that diagram, the interior walls show the diaphragm possibly running right through the wall, but the more interesting bit for us is on the right-hand side. You can see the diaphragm sitting or pocketed into the inner leaf of the cavity wall. What that tells us is that the inner leaf is actually load-bearing, while the out leaf is really just holding up its own weight. Alright, that wraps up our site investigation. So what we've got here is a two-story, stand-alone, unreinforced clay brick masonry building with cavity walls. We've nailed down the key material properties we will need for the rest of our detailed systematic assessment. Kia ora. Thank you.